9.5 meters below space and time. This crash did it. So how much interest? Well, I'm going to take this vector equation.
Hello and welcome back to Physics Teacher. I'm starting a new series on my channel, which is where I will teach you how to create your own physics simulations that you can use to then test physics concepts from high school physics. No coding is required, and it's a lot of fun. It's using this software you see right here called Algodoo. Okay, the address is up here. You can search for it, but I'll also post a link to it in the description. Now you can get this software on an iPad, or you can also download it for free on Windows or Mac. So let's go and see what this looks like. Now when you open Algodoo, it'll look something like this. You'll have a setup, tutorials, or lesson. I highly recommend starting with the tutorials. Right? You have a crash course, tools, a sketch tool. These first 3 tutorials definitely go through. It doesn't take long, just a few minutes each, and it will teach you how to use all the basics. So I'm not going to be going over the basics on how to use the tools. I'm going to be going over how to use additional things to actually create and analyze physics in these simulations. So just a brief overview. Up here on the left, you have your menu where you can open, save files, and call it for help in the tutorial if you need to review back to your tutorial. You have your toolbar over here. This top tool over here, the sketch tool, is the one you will use most often. I highly recommend it, and I highly recommend doing the tutorial for the sketch tool as well. Down here are your controls for the simulation, and up here are properties that you can use for different objects. So in today's lesson, I am going to go over projectile motion. So in projectile motion, you learn in physics that an object will have both a horizontal and vertical velocity, and those velocities are completely independent on one another. And there's probably a demonstration your teacher does where they throw a ball or an object horizontally off a table at the same time as dropping another object. Well, we can set up a simulation like I have here, and I'll show you how to do that after. But if we run it, you can see that this ball, which is given an initial horizontal velocity, and this ball, which drops straight down, hit the ground at the same time, meaning it doesn't matter that this one had a horizontal velocity if all you care about is which one's going to hit the ground first. All right, and we can create more elaborate experiments. So if we go over here, I've created this experiment. Right, where a ball can roll down the ramp, and then I paused it right when I got to here, and it's showing me the velocity at this instant, including its components, so it's vertical and horizontal velocities. And notice I set the vertical velocities for this ball going straight up, the same as this ball's vertical velocity. So when I run this simulation, their vertical positions always stay the same as each other because their vertical velocities are the same. It doesn't matter that one had an initial horizontal velocity. And so they perfectly collide afterwards. Now in reality, it would go a lot faster because you'll notice right here, I have a simulation speed on a little slower. But if we put it to real time, which would be 1, you'd see that happen. Alright, so we're going to start this fresh, and I will show you how you can build these simulations. So let's start by clicking on opening a new scene. Now, I like the chalkboard scene, but you can open any scene you want. So the first one, where we just sent a ball horizontal and one dropping. So let's create 2 balls. Here's one, and here's another. Well, that was a square. I am not good at drawing. One thing you could do though, let me get rid of this one. So I can right click on this one and click clone. So now I create an exact copy. And I want them to be at the same level when I drop them. So what I can do is sort of create something like this. And I can use this to pin it in place so it doesn't fall under gravity. And when I hit play, there. Now they're at the same level. Pause the simulation, and I can delete that. Alright, so how do I give this one an initial horizontal velocity? Well, I have the sketch tool on here. I'm just going to double click it. I believe right clicking works as well. And we can select velocities. Let's see here, I can give it an initial speed, and I can specify whether that's horizontal, vertical, or if I want, I can have it rotating as well. I'm just going to give it an initial horizontal velocity. Now, it doesn't show those vectors. So if you want to show the vectors, you're going to have to go up here to, here we go, visualization. We're going to click on velocities, and we're going to say view velocity. So now the velocity vector comes up. And I might want to see values as well. I might want to see components, angles, however much you want to see, you can click on to allow it to show you that. So there you go. There's the first simulation. You click run, and you can see that one went extremely far. So let me reset this, and I am going to zoom out. Here we go. I could just reduce the velocity, but I'll just zoom out, hit play. There. Perfect. If you want, you can slow down the simulation speed. Hit play. And you can see they hit the ground at the exact same time. All right, so very simple to start with. Right? Try it on your own if you have the software. If not, get the software and try it on your own. It's lots of fun. Okay, let's go to the second one that I set up. So I'm going to create a new scene. Again, in the chalkboard. So to start, I'm going to create a plane. Okay, so something like this. There we go. That's good enough. Right, if I want to rotate it because it's a bit too steep, I can click on the rotation tool here, and I can rotate it however I would like. Let's make it a little bit, there we go. Now I'm going to create a rectangle. Like that. Let's rotate it a little bit. Right there, and I'm going to create a circle. You don't have to use the sketch tool. You could use just circle right here, but I found the sketch tool to be very, very convenient. Oh, can undo. And what I'm going to do is I'm going to place it essentially over top. I want to resize it. It's a bit small. You can just find a good spot for it. And then if you double click on it, you can go to combine shapes, and you can use it to cut out a previous shape like so. So now I can delete this one. And this shape here, I can select it and move it right out. So now I have sort of somewhat of a ramp here. I can put that in there. I want to cut that piece off there. So I'm going to go to the cutting tool. And you can hold shift to do a straight line. Like that. Okay. And then it's cut. So I can select it and sort of move it out of the way there. And I can delete all these extra pieces here. All right, so there I have my ramp. So now I can create a ball. And I am going to want to pin my ramp in place. So now I can have the ball come down, goes on the ramp and over. It looks like there's still a little bump there. So let's move it over a little bit. Try again. Much better. Okay. All right. So now what I want to do is create something to measure that distance with. So I'm going to create a rectangle. like this. Notice as you're making it, it shows the distance. Right? And then when you stop making it, the distance goes away. All right, so I can double click on that, go to Appearance, and select Ruler. Okay? I also usually like, the lines all appear in white dashes, so I usually like to make the color black, so it's much easier to see. All right, so 1 meter, 2 meter, 3 meter, 4 meter, and so on. All right, run the simulation. And we're going to have to pin that in place. All right, run it again. There we go. Now what I'm going to want to do is I want to show the velocities on here. So I want to show values, angles, view velocities, show components. I want all of that. All right, play. Here we go. Now the velocities look pretty small, the arrows, so if you want to make them bigger, you can just increase your arrow scale. And now they appear much bigger. All right, so the ball only goes about 1 meter. So if I want to give it a more initial velocity, I can just zoom out, like so, and just raise it to a higher level. So it has more gravitational potential energy. Now if I hit play, picks up more speed, and goes a fair bit farther. Now what we can do is I can hit play. I'm just going to reduce the speed here. Pause it right at launch there. So right here, it was a little bit higher than I wanted it to be. So let me try that again. Yeah, that's pretty good. So right here we can see we have an initial vertical velocity of 6.3 meters per second squared. All right, so what I'm going to do is I'm going to create another ball here. I'm going to put it at the same level that this one's at. And I am going to give it an initial velocity in y of, again, 6.3. There we go. So now if we run the simulation from here, you can see horizontal velocity and vertical velocity are completely independent of each other. So those are the two simulations. Lots of fun, fairly easy to do. I hope I've taught you some new skills. We'll learn some more in the next video. But first, let me show you another simulation that I want you to try. So I'm going to go load up my other scene there. All right, so in this example, here I have a ball. I'm just going to place a square right here. And I can change the material. If you like, I can make it gold. Right. Now, let's say I want to launch this ball so I hit the gold. But here's the trick. The instant I launch it, the gold starts to fall. So where are you going to aim? Would you want to aim slightly below the gold brick, right at the gold brick, or slightly above the gold brick? Well, let's simplify the problem here. Let's say there was no gravity. Where would you aim? If there was no gravity, you'd probably aim right at it, just like I have it right now. You can actually test this. Right down here, there is turn gravity on and off. If you double click, you can even change the strength of gravity. Let's just have some fun and turn gravity off. So if we do that and launch it, you would think aiming right at it, bam, you hit it. And it turns out that even if I turn gravity on, as long as I aim right at it, you're still going to get that perfect hit. And it's basically just what we've been learning about. The horizontal and vertical velocities are independent. Right? And if I aim right at it, they are both falling downwards. Even though the ball's moving upwards, they're both falling down at the exact same rate. Right? Gravity. So it doesn't matter if I have gravity on. were both of them falling down at 9.8 meters per second squared, or if I turn gravity off. As long as I don't do anything weird, like make the gravity for the gold block different from the gravity of the ball. I don't think you can do that, but if you could, in that case, you wouldn't want to aim directly at it. The last thing we can do to end this is have a little fun. I can right click on this and I can liquefy it and turn it into water. So I hope you enjoyed this video. I'm going to post more episodes for Algodoo, where we're going to do more physics experiment, learn how to use the software, analyzing some physics concepts.